This is week 15. So it's the last week of instruction, which means today I'm finishing the section we're on. I will probably make a short assignment for it. That's not part of your grade. It's just practice. So I just have, I have to fix the example that we were doing last time. I'm going to pick a few random examples from the book. And then Wednesday and Friday, we review for the final. Okay, and I still haven't really picked a date, so I might just take a quick look right now. Happy Monday. And I would like to post the final by Wednesday and have you turn it in on the following Friday, the 21st, the last day. So that's the goal. But if not, I'll have it up by this Friday, due next Friday. Let's do, the goal is from the 12th to the 21st. And in that time, until this last day, you can still work on any past assignments. Just let me know. Okay, so I picked a problem and I was kind of in a hurry and totally made a mistake. So we're going to redo that problem. Except I'm still sort of piecing together the range, so I'll ask you guys for help when we get there. So your function, actually before we even do that problem, I have extra side notes. First of all, 9.3 homework, I'll try to make by Wednesday. Will be posted, but not part of your grade. All right, I'm going to get there. We want to talk about graphing inequalities. Alrighty, so if you have a strict inequality, use dots. And for less than or equal to or greater than or equal to, use a solid line to graph your function. So you're drawing a quick graph of the function and pretending like the inequality sign isn't there. And you're putting an equal sign there for a moment. But when you draw it, either draw it as a dashed line or a solid line. So I just did all these things really quickly when we were working on that problem before. But we're just going to slow it down, write these steps out, and redo that problem. test a point. So test any xy. And then put that into your expression, whatever problem you're working on. If you have a true statement, you've found a solution. I'm going to shade over the solution section. So you can test a few points if you need to, but we're probably only going to need to test one point. There's going to be a true side or a false side in most of these examples, I think. Anyway, you test points. If they're true, we shade over them. And if it's false, don't shade over it. Okay, I think that's it. So now I can put up that problem. It was f of xy equals ln of x plus y. Okay, and then we talked about, say you have ln of t. Let's draw that really quick. Okay, your t values have to be strictly greater than 0. The function looks like this. So for that function, we need x plus y greater than 0. And then we want to subtract x from each side. So we've got y greater than negative x. So now we're back to like those instructions I gave you earlier. We're going to pretend this is an equal sign. Or I guess graph y equal to x with dots. Oh, did it last time. Negative x, it's a negative sign. Okay, and then once we get that down, we'll test a point. Okay. It starts at the origin, intercept of 0, 0, you're going to have a slope of -1, so down 1 over 1, down 1 over 1, and use dots or dashed line. So this way. Okay, for y greater than -x, we'll pick a point, any point, like over here is -3, 0. So put in this for x and y. Is 0 greater than -3? Nope, that's false. So that's not a solution, and this is not the solution section. It's on the opposite side over this way. And you can test a point over here if you want to be sure, or like maybe 1, 1 or something. This is the solution section. Okay. Oh, okay, thanks. Yeah, compliment about the haircut. Did it myself. Thank you very much. Back to math. So the range part is something I started to do on a scratch paper. So let me know what you think of the solution once we get there. So I got my domain. Let's write it as a set. Yeah, let's write the set. Let's do this. So sketch. Domain. Okay, we're gonna have pairs of x, y's. And this exists in R squared. We're gonna add this part to it. So x is in R and y is in R. Both of these numbers are real numbers. Such that y is greater than -x. Okay. Your function is f. It takes in little x, y values. I'm just going to show you all the numbers I tried. So I tried 0, 0. I put in a -100, 0, and a 0, +1000. Just playing around. And then I put in small numbers, like 0.001, comma 0. And let's put in like a negative number, a large negative number, a large positive number, got a little small number. I think that's good enough. So let's try these. F takes 0, 0 to ln of 0 plus 0. Which is undefined. Okay. So This is then the domain ln of 0 is not in the range. Let's see, I think I'm doing this right. Let's then put in this input. We're looking for the set of outputs. So if we put in negative 100 for x, get out ln of negative 100 also does not exist. Put this number in and get this number out. Let's see. Got ln of yes, by the way, we have a final exam. I'm going to have it available hopefully by Wednesday, and you can work on it for like a take-home test for a week, and it will be due on Friday the 21st. It's mostly going to be like a third exam, but I might throw in a few questions from earlier in the semester. Yeah. Okay, so let's see what we get. What kind of outputs do we get? I put in actually 0, 100. I got out 4.605. So what I'm wondering is if we can have an output of 0 or an output that's a negative number. Because I've got this positive number as an output. Let's put in a few more inputs and check out our outputs and try to figure out what this set is. And this, and we'll try this next. Okay. I'm just using Desmos for a sec. Let's see. Oh, cool, I got out a negative number. Sweet. So ln of 0.001 is negative 6.9. Oh, yeah, cool. So I have a feeling that this goes down towards negative infinity, then up towards positive infinity, but we can put a few more inputs in just to check. Let's go even smaller and also a little bit bigger for x or y. Let's try like it. I don't think it matters which one is which. X could be 0.00001, comma. Let's just put 0. Or let's go with 50. Let's go with 50,000. Comma 0. Okay, and then let's do this math together. Cool. So add some zeros. Got to negative 11.51. And I'm going to put in a very large value. And I got out 10.8. Lost you guys. No. How do I fix this? Resume something. Stop. There you are. Okay. So that was 10.8. Okay. So this set keeps going as these numbers as your x plus y value gets smaller and smaller, the outputs go towards negative infinity. And as x plus y becomes larger, the range goes to positive infinity. So it's going to be all real numbers. Okay, let's I want to skip this one because it's very similar, but we've got time. Okay. Let's do something sort of similar but different. So f of xy found this one. It's ln of x minus y squared. There's a lot of the same ideas, so we'll do this a bit more, the list a bit more quickly, which sounds kind of weird, but still. Don't want to make mistakes. Okay, we need this value to be greater than 0, just like the last problem. Okay, let's do x greater than y squared. Okay, so the sets all x, y, and r squared such that x is greater than y squared. And the graph, it's a sideways parabola. And then we'll go through drawing it with dots and testing a point. So through 1, 1, and it's dots. Same on this side. Like a positive root x and a negative root x. Sort of. Okay, pick a point. I picked this point like over here. Let's call it negative 1, 0. Put that in for x. This is going to be my y. If it's true, then I'll shade over this area outside of the parabola. If it's false, I'm going to go shade inside this section and not shade over that point right there. That's on the other side of the graph. Okay, testing negative 1 greater than 0 squared. So it's negative 1 greater than 0. So that's not a solution. In here, we could test points if we want to find out this is the solution section. I feel like 1 point's enough. But still, it doesn't hurt to check. And let's see, the same kind of idea is behind the range for this function. So any value that you put in as x minus y squared will give you positive outputs as that value becomes bigger, or negative outputs as it becomes smaller and smaller, getting closer to 0. So the range is also all real numbers. Let's see if there's something more interesting in the book. Let's try this one. So it's an e to the, let's make it kind of easier. Let's do e to the x minus y. Okay, so your set of inputs and your set of outputs. So let's first think about something like e to the t. Okay, it goes through 0, 1, and up exponentially, and approaches that line t equals 0. So through here, and oh, actually, yeah, it's still good. There's an equal sign, and this is just for scratch work. So. Okay, we're gonna go slowly. All right, values of t can be negative infinity, and they can go up to positive infinity. So there's no restriction really on what x minus y could be. It doesn't have to be strictly greater than 0, or it could be any number. Cool. So let's see. So I feel like the set would just be all x, y, and r squared. There's no like extra requirement that we need. But let me see. Domain would be the set all x, y, and r squared. Do we need anything else? X minus y could be any negative number. It could be 0 because e to the 0 is just 1. It could be any positive number. Be some positive number. I think that's it. Just close it up. And let's play with some points. So we'll put some inputs in there, any input we want, and see what outputs look like. And that will be, the set of outputs will be our range. Oh, sorry. Okay, putting it in. Let's definitely try 0, 0. Let's try a large value for x, like 200, comma 0. Let's try some negative number for x. negative 100, 0. Let's start there. So we're going to do f of x comma y equals e to the x. Was it x minus y? I think it was, so minus. Okay, so e to the 0 would be that first output. Okay, e to a power of 200 minus 0, so e to the 200. It's going to be some very large positive number. We'll calculate in a second. E to the power of negative 100. So it's going to be like this really, really small positive number. So the range for this function should be the same as the range for that function e to the t. Should go from 0, not including 0, and up to positive infinity. Let's just see what these actual numbers are, just to kind of be more confident about that. Okay, so e to the 200 is a huge number, 7.2 times 10 to the 86. So definitely going to go towards positive infinity. Let's do that very small value, negative 100. So this is a very, very small, but still positive number. So it's greater than 0, but very, very, very close to 0. Like 0, like, I can't even say. 0.37 times 10 to a negative 44. So 0.0 and then 44 zeros after that, and then 372, all that good stuff. Okay, so it's still a positive number. It's a very, very small one. 3.4, 10 to the negative 44. Our range is going from 0 and above, like this. Sweet. Okay, I think we could do one more. Ooh, I know. Let's divide by something. Let's do something like f of x, y is, I want to put like 2 over x plus 2y. There we go. Okay. Before we talk about this, when you're kind of looking at your function, whatever function, I would keep an eye out for square root signs. Anything under a square root needs to be above, greater than or equal to 0. For any ln in your function, ln of the value, that value needs to be strictly greater than 0. So the ln or the square root. Also, there's division. You don't want to divide by 0. So anything in the denominator is not equal to 0. Or you don't want to have equal to 0. So we will let it equal 0, find out what those values are, and then they can't be in the domain. Before I get there though. Okay, so look for square roots. Look for, let's put t or something, like ln of t. And something like this, like a number over t. You just don't want t to equal 0. So here, t can be greater than or equal to 0. Here, t is strictly greater than 0. This kind of function, you need t not equal to 0. Anything else? I think that's it. That's all I can think of right now. So let's try to do this. Let's consider x plus 2y equal to 0. Then let's do 2y would equal negative x. Divide both sides by 2. And have y equal to negative x over 2. So the domain we would write as a set, and the graph is that picture we're going to draw. Or actually, the graph is technically also a set. Okay, let's write the domain. Okay, we get all x, y in r squared. Such that we'll put 2y equals negative x. Oh, wait. It's actually all values except for that value. Let's see. We need I think we just put a slash. Okay, let's see if we can piece this together. Where got x's and y's. I'm going to think about graphing. Actually, let's divide this up. Y equals negative x over 2. And I think I will, what I'll do is I'll put dots there. That will represent that we're not going to use that line, but everything else is going to be used. So I'll shade everywhere except for the dashed line, and that dashed line is what we're removing from the domain. Okay, so you start at the origin. You go down 1 over 2. And then down 1 more over to the right, 2 more. Down and over, down, over. And then you're going to draw this sort of missing. That's like a missing strip from the domain, which is everything else except for that dotted line. So maybe even like circle this part that like don't use this stuff. We can like really close to that line, but not actually use any of those values. Okay, Let's try to get the range and call it good. So it was 2 over like x. Erased it. Plus 2y. I think it was plus 2y. Okay, so let's put in like a really big number. So 500. But some kind of super small number. It doesn't really matter, at least for this function. It doesn't look to me like it matters if I put that number here or there. We're just going to add them together anyway. So we're going to do 0, comma, negative 2000. Also give 0, 0 a try, just for fun. And good for now. So let's take these inputs, see what their outputs are, work it out in Desmos. Oh, okay, well, it's cool. We're putting in our x and y's. X is going to be 500 to begin with, and then we're going to multiply y. That's 2 times 0. Cool. Some super small number, 0.004. Okay, we can't put in 0, 0. That was not actually part of the domain. Shouldn't have been that. But if we put in 0, 0, the output is undefined, which is just another confirmation that we don't want those x and y values from that line, which did include the 0.00. So I shouldn't have even put that in for an input. Oh well, it's cool. Let's put in 0, negative 200. Let's see if this one, plus 2x, almost done. Oh, okay, negative 0.005. So I'll double check on my own, but I'm thinking that as we put in larger and larger x or y's and the denominator becomes bigger, this value gets smaller and goes towards 0. It could also be negative, because if you have a negative number in the denominator, it makes this whole value negative. Of course, we had a positive output, and we could have this value in the denominator getting smaller and smaller, which makes the whole value bigger. So the range should be all numbers. I'll double check on my own, but that's the end of class for today. We're going to start to review for the final on Wednesday. And I guess let me know if you have any topics that you want.